Welcome to aminacademy.com. In mathematical formulae for derivative of vectors, let us discuss. What is derivative of vectors? The derivative of vector is found by differentiating each component of the vector with respect to the variable of interest. Look at here. Suppose a vector R with component x, y, z is defined in terms of t. That is, R is equal to x of t, y of t and z of t. Then further we can say it is R equal x of t, y of t, z of t, the same. Then the derivative with respect to t of that vector is dr by dt is equal d by dt of xt, yt and zt, which is further we can write this as dx by dt, dy by dt and dz by dt. Now, in generally, vector a of u is equal to, we can write a1 of ui, that is a1, a2, a3 are components, and plus a2 of uj vector k and a3 u of k vector k of the scalar variable u is given by here scalar variable u is given by now the differentiation of vector a over du, that is dA by du is equal limit vector a, that is delta tends 0, vector a of u plus du minus vector a of u divided by du. This is a general definition for differentiation of vector, which is further we can write this as dA1 by du I vector plus dA2 over du j vector and dA3 with respect to du k vector. Next, some formulae involving derivatives. Look at here, some general formulas involving derivatives of dot and product functions. Here, d by du of a vector dot b vector, that is derivative of cross dot product, is equal vector a dot db by du plus delta a vector by du into b vector. Okay. Here. Next one, d by du of a cross b, that is a vector cross b vector cross, equal vector a cross db by du plus da by du cross b vector. Next, d by du of, that is differential of vector a dot b cross c is equal, look at here, this is d a vector by du dot b cross c plus a vector dot db over du into cross c vector plus a vector dot b cross dc by du. Remember this result. Next one, vector a dot d a by du is equal a, that is modulus of vector a, that is a dA by du. Next one, vector a dot dA by du is equal 0 if modulus of vector a is a constant. If it is like, we can write this as 0. Next, del operator. This is a del operator. You can say del operator is like, the operator del is defined by del equal I vector dou by dou x, the partial derivative, plus j vector dou by dou y plus k vector dou by dou z. Next, the gradient. The gradient is the following result. We assume that for the gradient we have to assume this: u equal u of xyz, v equal v of xyz, those are functions. Then vector a equal vector a of xyz, vector b equal to vector b of xyz, have partial derivatives. then we can write gradient of u. If the function is like, we can say the gradient of u, that is grade u, then that is equal del u, which is equal I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z of u. That is further equal, look at here, this is dou u by dou x I vector plus dou u by dou y j vector plus dou u by dou z k vector. This is the gradient. Next one, the divergence. What is the divergence? The divergence of vector A, we can write this as div, divergence of vector A, that is further equal del dot A vector. Del dot A vector is called a divergence, which is further equal I vector dou by dou x, dou means partial derivative, plus j vector dou by dou y plus k vector dou by dou z dot. Vector A can be written as A1, that is components of A1I plus A2j plus A3k vector, which is further equal dou A1 by dou x, dou A2 by dou y plus dou A3 by dou z, which is called the divergence. Next is the curl. The curl of A vector is, we can write as curl A vector, which is further equal del cross A vector. Del cross vector A is called curl of that vector A, which is further, we can write as I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z cross. Cross of vector A is written like A1I vector plus A2j vector plus A3k vector. You know, this cross product can be written in terms of determinant. That is, we have to write I, j, k. Then this come here, second row, dou by dou x, dou by dou y, dou by dou z, and third row, which comes A1, A2, A3. Then here we know that expansion of determinant, we can write this I vector is the minor product, that is dou by dou y A3, then this minus dou A2 by dou z of I plus this minus comes, so minus j of dou A1 plus 1 yes. Then j of dou A1 by dou z minus dou A3 by dou z, that is here. For j, we have to multiply these two things. Then because here actually minus we need, but we change the order here, so it becomes plus. Next one, plus k vector into these two things, that is dou A2 by dou x and dou A1 by dou y, k vector. Then next the curl. Next one is the Laplacian. The Laplacian of u is defined as del square of u, which is equal del dot delta u, which is further equal dou square u by dou x square, dou square v by dou square u by dou y square, dou square u by dou z square. Then next one, Laplacian of a vector can be written as del square by a vector. Here u comes, here a comes. Here dou square a vector by dou x square plus dou square a vector by dou y square plus dou square a vector by dou z square. Next is the harmonic operator. The harmonic operator on u is defined as del power 4 u, which is equal delta square of delta square u. This is delta power 4u. Then it is expanded dou power 4u over dou x power 4 plus dou power 4u by dou y power 4, that is fourth derivative, plus dou power 4u over dou z power 4 plus 2 into dou power 4u over dou x square into dou y square, then 2 into dou power 4u over dou y square dou z square plus 2 dou power 4u over dou x square by dou y square. Next one, some miscellaneous formula involving delta, del, that is del of u plus v equal to del of u plus delta of v distributive. Then del of dot a vector plus b vector is equal del of dot a vector plus del of dot b vector. Then next one, del of cross a vector plus b vector is equal del of cross a vector plus del of cross b vector. Look at here the result. Next one, del of dot u a vector is equal del of u dot a vector plus u into del of dot a vector. Next one, del cross u into a vector which is equal del of u cross a vector plus u of del of cross a vector. Look at this result. Next one, next here, del dot a cross b vector, a vector cross b vector, which is equal b vector dot del cross a minus a cross dot del cross b vector. Next one, del cross a cross b, all are cross here, cross product of 3 here, which is equal b dot del of a vector plus a vector dot del b vector minus a vector dot del b vector plus a vector of del dot b vector. Next one, del of a vector dot b vector is equal b vector dot del of a vector plus a vector dot del of b vector plus b vector cross of del cross a vector plus a vector cross of del cross b vector. You have to remember this lengthy, but by practicing you can remember this. Next one, del cross of delta u is equal to 0. This result is 0. That means cross product of del and differential of del of u is equal to 0. That is curl of the gradient. This is curl of the gradient of u is 0. Curl of the gradient is always 0. Next one, del dot del of cross a vector equals 0. That is, this is a divergence. Divergence of curl. This is curl of gradient. Here, divergence of the curl. Divergence of the curl of A is 0. Divergence of the curl of A. The divergence of the curl of A vector is 0. Next one, curl del cross A vector, which is equal del of A vector minus del cross of A vector minus del square A. Del square A vector. Yeah. If the result to final result del of cross A vector is equal del of del dot A vector minus del square A vector. So far we discussed about differentiation of vectors in different forms. That is, different formulas we discussed here, like dot product as well as cross product. We have done. Please subscribe our YouTube channel.